Chapter 1 real number exercise 1.2, that is here it's to prove the irrational number. We know here in the syllabus we have to prove the irrational number, that is root 2, root 3 and root 5. These are only after root 2, root 3, root 5. These are included in the syllabus. First, we know it is a irrational number. First, what is a irrational number? Irrational is number that is not a terminating, not a reoccurring. Means after finding the value of root 2 or finding the value of root 2, already it's done in the class, it's already dealt in the class 8. After finding the value of root 2, you will get a certain number. That numbers will not repeat, it will go after the infinity. That's why it is a irrational number. So we have to prove it. That is a theoretical. Now for proving root 2, root 3 and root 5 all are similar. If you are able to prove the root 2 irrational numbers, you can solve the root 3 and root 5 along with the rest of the prime numbers. So first, for solving the root 2 as a irrational number, we have to consider that we will prove it by the contradiction. What is a contradiction? Means we will consider root 2 as a rational number and we will prove that it is not a rational number, so it have to be irrational number, because we have our real number. This is the real number. In real number we have a rational number, rational, that is Q, and irrational number IR, and combination of these two, this is the real number. So combination of this rational and irrational, that is a real number. So we are going to take root 2 as a irrational as a rational number. Then we will prove that it is not a rational number. So if it is not a it is not a rational number, so it have to be irrational number. So root 2 will be irrational number. So we call it a contradiction, which is we have considered it that our consideration is a wrong. So we have to prove in this way. So first in our exercise it's given. So first I'll solve the exercise, after that I'll solve the example also, because NCERT each and every question is important. Exercise as well as the example, all are different. So first prove that root 5 is a irrational number. We have to prove that root 5 is a irrational number. So we will consider if possible let root 5 be a rational number in simplest form. Now what is the simplest form? Simplest form is after, because it will be in the form of P by Q, and this cannot be this common factor, a common factor of P and Q. Either you can consider P or Q, or you can consider A by B, both are correct, but their common factor it was only 1. This number can be divisible by 1, not any other number. That's called a simplest form. So therefore root 5 is equal to A by B. This is the simplest one, and B cannot be 0. In the rational part, the denominator cannot be 0. So B is not equal to 0. So after that, we have to prove that root 5 is a irrational number. So what now our target is to remove the square root. This is a square root. For removing a square root, you have to multiply both side by the, means you take the square root on the both side. So squaring both side. So root 5 A by B whole square, that is squaring both side. Now what do you mean, what is the value of root? Root means this root is always equivalent to half. So this root and this root and square will eliminate, so this will be 5 equal to, this will be a square divided by b square. Now bring the b square this side. It is a divide this side. If you come this side, it will be multiply. So 5b square equal to a square. Now this number is divisible by 5. Why it's divisible by 5? Here 5 is there. So this number also divisible by 5. There is no 5, but this is divisible. Why? Because this is equal to, means this and this are equivalent. Since this is divisible by 5, why it's divisible by 5? Here 5 is there, so it's divisible by 5. So this also divisible by 5. Why this is divisible by 5? Because these are equivalent. So 5 divides, we can write 5 divides a square, that is also correct. A square is divisible by 5, that is also correct. So 5 divides a square implies, therefore 5 will divides a. 5 divides a. See, when let's see, when 25 is divisible by 5. If 25 is divisible by 5, therefore 5 also divisible by 5, because 25 is a 5 square. So this is the theorem. Now let's take, we have to prove that there is one, because we have taken that root 5 is a rational number. We have only the simplest form is we have only the common factor, that is 1. So we will check, is there only the 1 is the common factor. If it is a 1 is a common factor, so it will be in the simplest form. If it doesn't get 1 is a common factor, so it cannot be a rational number. So now we got that this a is divisible by, this a is divisible by 5. Now we will check that is b divisible by 5. For that, let a is equal to 5c for some integer, c. So now in place of a, write 5c. So we have, instead of a, in this equation right, in this equation, right, take it as a equation 1. So putting or substituting, putting a equal to 5c in equation 1. So instead of replace the a by 5c. So 5b square is equal to, instead of a, 5c, now whole square, 5b square is equal to 5, that is 5 square 25, c square. Now this is divisible by 5, so eliminate 5, this is 5 1s are 5, 5 5s are 25. So we got b square equal to 5 c square. See, now this is divisible by 5, because here 5 is there. So this also divisible by 5. Why it is divisible by 5? Because it is equal to, if any number divides this number, so that number will divide this number also. So therefore, or implies 5 divides b square. So implies 5 divides b. We have taken that only 1 is the common factor of a and b. Only 1 divides a and b, but we got 5 divides b and 5 divides a. So this is not correct. We have considered that only 1 divides, but we got 5 divides both a and b. So this is a contradiction. Therefore it cannot be, this is not a rational number, it is an irrational number. Thus 5 is common factor of a and b, which is contradiction. We have considered that only 1 is a common factor of a and b. Simplest form means 1 is a common factor of a and b, but we got 5 is a common factor of a and b. So which is contradiction? Means that is our assumption is wrong, which is contradiction to our assumption. That means we have considered that is wrong. Therefore root 5 is irrational number. We have considered it is a rational number. Rational number means rational number in the simplest form. but we got 5 divides both a and b, so that is wrong. We have considered that root 5 is a rational number, that is wrong. So it have to be irrational number, because in the real number either we have the rational number, if it is not a rational number it have to be irrational number. Since root 5 we have considered a rational number, but we got it is not a rational number, so it have to be irrational number. So therefore root 5 is a irrational number. So this is the result. If it comes in the means MCQ form, direct root 5, that is a irrational number, clearly visible. So that time no need to prove it, just write it is a irrational number. Now come for the Roman number 2. Prove that 3 plus 2 root 5 is a irrational number. If it come to the MCQ, it will be, you can write directly irrational number, because if you multiply any irrational number by a natural number, it will give a irrational number. Again, if you add this with any natural number, again it will give a irrational number. If you add the rational number, if you add the irrational number to any of the number, it will give always irrational number. If it is in the MCQ, write it directly, but it's not in the MCQ, you have to prove it. So prove that 3 plus 2 root 5 is a irrational number. Now before solving this, if it comes to the exam, first see the mark. What is the mark it carries? If it carries 2 or 3, that time just you write it, we know that root 5 is a irrational number if it is carried 2 or 3 marks. But if this question carry, it's the highest mark, that is the 5 marks, that time first you have to prove that root 5 is a irrational number. After that only you are going to prove that after adding the irrational number and the 3, you will get a irrational number. So before solving this in the exam, see the question how much it carries. If it is the 2 mark or 3 mark, then just you know that root 5 is a rational number, you can continue. But if it is a 5 marks, first prove the root 5 is a irrational number. Now already root 5 is a rational number, we prove in the question number 1. So now we were going to prove that 3 plus 2 root 5 is a irrational number. Means after knowing root 5 is a rational number, we are going to prove that adding the irrational number to any numbers, it gives the irrational number. So for prove it, this is a little bit theoretical. Consider the if possible, always write if possible, or if you doesn't want to write, just you can write let, consider, that is also correct. If possible, let 3 plus 2 root 5 is rational number. Same, consider the rational number, you are going to prove it is not a rational number, so it is a irrational number, because in the real number we have only rational number or the irrational number. If it is not rational, it have to be irrational. So rational number, and mention it in the simplest form, in the simplest form, or if you want a simplest form, and you can write also 1, therefore, or therefore 1 is the common factor, common factor, FACTOR. So 3 plus 2 root 5, or if it is a rational number, that is always in the form of the fraction, there is a divide b. Instead of a b, you can take any alphabet, a divide b, and b does not equal to 0, down denominator cannot be a 0. So now for solving this, this side, in the left side, this side, keep only the root value. Now rest take this that side. So now we have this root value, but only the root form. So here our main target, take the 3 that side first. So 2 root 5 equal to, now before taking that side, see the sign of the 3. What is the sign of the 3? Here nothing is given. Nothing is given, that is the positive. If the positive, take that side, means go other side of the equal to. Its sign have to be opposite. What is the opposite of the positive? That is a negative. First write it what is given before, what is the value this side. We have a by b before. Now take the 3 that side. So this is check the front. So in front of the 3, that is the positive, nothing is there, so there is a plus, and plus if you go that side, you will give minus 3. Now For solving this, you have to solve it. 3 first, if you go for the addition of the fraction or the subtraction of the fraction, first both have to be a rational number. One is a natural number, one is a rational number. You cannot add it. So whenever it have a natural number, and we know that every natural number is a rational number. So this is a natural number. How are you going to make it a rational number? Just divide it by 1, because we know 3 is also equal to 3 and 3 by 1, that is, or we doesn't write down denominator of denominator 1, but here we need it, so write it down. So divided by 1. If you want to keep it here, write in the next step. So a divided by b divided, make it fraction. So 3 by 1. Now it became a fraction. If it became a fraction, now that is, do the subtraction. So 2 root 5 equal to divided by, now for solving the fraction, first what you have to do, you have to take the LCM of this. Here 2 and 1 LCM, it will be b. So after taking the LCM, now divide these two. B divided by b, so 1 into a, that is a, minus divide the b by 1, it will give b, so b into 3, so it will be 3b. Now this side we are going to keep only the irrational number, that is a root 5. Now I have the 2. Now take the 2 that side. Now be careful. Now whose sign we are going to check? Now if you have the 2 number, that is a, b, check the middle one, not the front. If it is single, here 3 is a single, that you check the front part. Now you have 2, here 2, that is AV, that time check the middle, not the front. So see, now 2 root 5, what is there in the middle? Nothing is there. Between the two number, nothing is there. When two alphabet, nothing is there, that is the multiplication. So here is the multiplication. If it is a multiplication, it will go that side. What will it give? It will give the divide. It will be opposite, reciprocal. So it will give the opposite. So multiplication, it will give the divide. So here is the multiplication, it will go downside. So it will be root 5 equal to a divided by 3, b divided by b. See now, this is an irrational number. How it is an irrational number? We already know that root 5 is an irrational number, but this is a rational number. Why it is a rational number? Because it is something divided by some number divided by again any other number. So it is in the form of a fraction. This side is an irrational number, this is a rational number. Can it be equal? So it is not possible. So therefore again we got the contradiction. A minus 3b divided by b is a rational number. Rational number. But root 5 is irrational number. Irrational number. So rational number and irrational number cannot be a 0. Therefore also, but root 5 is a irrational number, therefore which is contradiction, which is contradiction, therefore 3 plus 2 root 5 is irrational number.